In this section and the final section of this course, we will study about an important machine learning technique called transfer learning. So one question that always comes to my mind when I do machine learning or deep learning task is, what if we want to transfer knowledge from one network to another network? Suppose you are a physics student and your friend is also a physics student, and there is some important concept that you and your friend are trying to grab from like a month or so. But after studying for a week or so, you are able to grab the concept and finally you make your friend understand the concept. So this way the knowledge transfers from one human being to another human being. So is this possible in case of a neural network? Well, it is. So transfer learning is a method in supervised learning in which a model developed for one task can be reused on another similar task. If you see the definition of transfer learning, it is clearly mentioned that the tasks are related. So if you are a physics student, your friend also has to be physics student to understand what exactly you are saying to him. Another question comes up that why do we need transfer learning? Why do we need to transfer knowledge from one network to another? So it turns out that it is very helpful in saving the computational power and time. Suppose you have trained a network for 28 days continuously and now you want to train another network that is actually performing another similar task. So you don't want to actually train your whole network again. So what you want to do is you want to reuse some of the weights of the previous network in your new network. So if you have less data for a new problem statement, then a pre-trained model helps to achieve the state-of-the-art results. Like in section 3, we talked about convolutional neural networks in which the earlier layers of the network learn general features, while the later layers learn the specific features. So similarly, you don't have to extract the general features in every problem statement. What you can do is you can have a pre-trained neural network which is capable of learning general features, and you actually transfer those weights to the new network. So I'll explain this via a diagram. So suppose you have a problem. For a problem in a data science, it means you have data. So you have data and now you perform feature engineering or you pass it to deep learning to actually figure out the features itself, and then you have a finally trained model. So when you say you have a trained model, that trained model is a set of weights. So those set of weights are the weights of the features. What you want to do is you want to reuse these weights in a new model. So in a transfer learning pipeline, you have data, you have a pre-trained model, that is you have a pre-trained set of weights, and then you get a new model which is based on the feature optimization on the new data. So what I'm trying to say exactly is that your new model fine-tunes the weights of the previous model. So you already have one weights and you are actually trying to fine-tune the weights in order to achieve the task on your new data. So this is the way how the transfer learning pipeline works. So let's take an example of a convolutional neural network that we studied in section 3. As we said that the lower layers in the CNN learn general features while the later layers learn the specific features. So what exactly do we do when we do transfer learning in a CNN is we actually freeze the weights of the earlier layers of CNN because they are bound to learn the general features. So if you have a pre-trained CNN, it is sure that the earlier layers of the CNN learned some general features and you do not want to learn the general features again. So in that case, you have to freeze the earlier layers of CNN and just retrain the last layers of CNN to actually adapt to your data. So there are some pre-trained neural networks already present for CNN, for example, ResNet, GoogleNet or VGG. So transfer learning is also very useful in case of NLP or RNN tasks. So for natural language processing, we have a lot of pre-trained models, one of which is a very famous model given by Google, that is Word2Vec, and another Stanford Growth model. So Word2Vec is one of the best techniques to learn the word embeddings which can be used to help machines understand a natural language. So it contains word embeddings that actually separate out words based on some features.